Well, hello everybody. Well, we're sorry that you missed our day 3 lesson in chapter 13. So, guys, what you should have in front of you today, or that you'll need to have in front of you, you'll need to have that note card that we've been working with quite a bit here lately. If you do not have that note card, coming up I have a slide that you'll need to hit pause on the video, and you'll need to write down 4 formulas that we're going to use over and over and over today. If you have your note card in front of you, then you're setting really good. You'll also need your calculator today. We're going to use that quite a bit at first, and then we're hoping to phase you out of using your calculator some. You'll need that class note sheet that says Day 3 class on there. It should also say Lesson Master 13.4. And then smile, because I think today is really an easy day. One of the easiest days that we've had since we started the trigonometry section. So hang with me today and you're going to be pretty good. But where I got to take you today, guys, this isn't on your note sheet. You know how to find all of these via right triangle. Sine, cosine, and tangent of 30, sine, cosine, and tangent of 60. Where I need to take you today, though, is how do you find the exact value of something like cosine of 75 degrees? If you type that in your calculator, it does not come out pretty. I need to show you how to find the cosine of something like 15 degrees. Where these come from is the manipulation of these trig functions. But here's where I'd like to take you first. Like I said, this is not on your note sheet, but guys, pretend that right in front of you here is a 30, 60, 90 triangle. So let me put a 30 there, a 60 there, and of course I got my right angle. What I'd like to go is just find sine, cosine, and tangent of 30 degrees. Well, that's not going to be bad. Remember, this is a special right triangle. Here's a 1, here's a 2, there's a radical 3. So now let's just go beat it up real fast. You'll see why I'm doing this here in about a minute. The sine of 30 is going to be 1 over 2. And my touch screen jumps a little bit. I'm going to come back here in a little bit, and we're going to look at these decimals. What I want to do on these first slides is there's about 5 or 6 decimals I want you to memorize that'll help you tremendously in our next few lessons. Let's go get the cosine of 30. That's going to be the adjacent over the hypotenuse. So it looks like I'm going to have radical 3 over 2. The tangent of 30, the opposite over the adjacent. So I'm going to have 1 over radical 3. Let's get rid of that radical 3 in the denominator and have radical 3 over 3. Now, I had a little typo here, so I corrected it. Now let's go do all those same things, but let's go from the 60 degree angle. So now let's come up to that 60 degree angle. Let's go get the sine of 60. Well, from the 60 degree angle, the sine is the opposite over the hypotenuse. So that's going to be radical 3 over 2. Cosine of 60, the adjacent over the hypotenuse. And the tangent of 60, the opposite over the adjacent, so square root of 3. Now I'd like to pause for 1 second, guys. Let me bring up my calculators because I'd like to show you something now. And this will go back and forth a little bit. But guys, I've got my calculator set to into degrees already. So let me look at cosine of 30. As a decimal, it says 0.866025. Check out what radical 3 over 2 is going to be. If I can find my radical sign. Notice that we're going to get the same decimals. So one thing that I want you to know, whenever a radical 3 over 2 shows up, that decimal is about 0.866. So notice that it showed up once there and once there. What I'd like for you to do today, and I've got this on a slide coming up, but when a 0.866 shows up on your calculator, I would like for you to know that's radical 3 over 2. The only way I can change it then is to put a negative in front of it. Let's pick on tangent of 30 now. That means that square root of 3 over 3 is the same decimal as about 0.577. This decimal does not show up a lot for us, but when it does, That's one of them that I'd like for you to know. So 0.866, that one's going to show up about 20 times today, radical 3 over 2. Radical 3 over 3 probably won't show up today, but I want you to know that's 0.577. 1/2 is 0.5, that's easy enough. The only other decimal that's going to show up is the square root of 3. The tangent of 60 was the square root of 3. Notice that's about 1.73. So guys, if you really look at it, there's an easy decimal that you don't have to memorize, but 0.866, 1.73, and 0.577 shows up. Now let me come over to, let's do the same thing, and I know this triangle's not drawn to shape, but let's pretend that this is a 45, 45, 90 triangle. And then once again, that's going to be a 1, that's going to be a 1, that's going to be a square root of 2. Now let's go get the sine, cosine, and tangent of 45. It doesn't matter which angle you start with, so let's go right here. The sine is going to be 1 divided by square root of 2. Let's get rid of that and get square root of 2 over 2. The cosine is the adjacent over the hypotenuse. Another 1 over the square root of 2, so square root of 2 over 2. And tangent of 45, the opposite over the adjacent, 1. Okay. Now I'm going to come back to my calculator real fast. Here comes our last decimal I'd like for you to get used to. If square root of 2 over 2 shows up, I'd like for you to get used to that being 0.707. So guys, there's a total of 5 decimals I'd like for you to know. If you need to pause the video and scribble these down for now, you can, but I don't want you to write them on your note card. I want you to memorize them. Because guys, there's a whopping 4 or 5 of them, right? 0.5 is 1/2. That's easy enough. Here's the major ones that's going to show up today. Over and over and over, you will see. The 1/2 will show up a lot, but 0.707, radical 2 over 2. That'll usually show up when we're dealing with a 45, a 135, something like that. 0.866 is going to be your radical 3 over 2. 0.577, radical 3 over 3. And 1.73 is radical 3. So please memorize those for us. You'll see why I'm hitting those. You'll see why I spent about 5 minutes here talking about those. But guys, on your note card, please notice that under the area that it says sum and difference of angles formulas, there's 4 formulas there. I'm not going to take time on this video to prove them to you. That's where it comes from. It's really about a 10 to 12 minute proof. I don't want to spend time on the video to do that, nor do you want me to. But guys, here's some formulas that I need you to have either on your note card or pause the video and write those down. Group the 2 sines together, group the 2 cosines together. But other than that, if you would, come over to your lesson master that says cosine of 75. Let me show you how we're going to attack these now. 75 is not one of those 30, 60, 90, 45, 45, 90 angles that we come up with. So guys, here's what we got to do. I've got to write this as cosine of something. Now guys, what you get to use is you can use any multiple of 30. And you can use any multiple of 45. The reason we get those come out of our special right triangles. And what I mean by you can use any of those, you can use any of those angles to rewrite 75. So here goes maybe a first one. I'm going to rewrite 75 degrees as 30 plus 45. It's got to sum up to be 75, and I got to use numbers that I know, 30 and 45. Now, if you would, peek at your note card. You just decided to use this formula right there, cosine of alpha plus beta. You decided to use that formula. And if you look at what that says, it says this. Cosine of 75 degrees is going to be cosine of 30 times cosine of 45 minus sine of 30, sine of 45. And let me get rid of this stuff now. This is the hardest part of the day right here, deciding what to use. Sine of 30, sine of 45. Now guys, here comes all those numbers now. Here's what I'd like for you to do. Make sure your calculator is set in degree mode. I'm going to quickly go cosine of 30. And my calculator says 0.866. So I'm going to write down square root of 3 over 2 times. I'm going to launch my calculator again, and I'm going to go cosine of 45. Notice my calculator said 0.707. That is radical 2 over 2. Then there's a minus sign. And now I need to go sine of 30, 0.5. So I'm going to have minus 1/2 times, now let's go get the last one, sine of 45. After you do this one a few times, you're going to automatically know it's 0.707. So radical 2 over 2. Okay. Now the easy part, guys. Notice that my denominator, 2 times 2 is 4. 2 times 2 is 4. My denominator is 4. Now just so simplify your numerator. Square root of 3 times square root of 2 is square root of 6. Minus 1 times square root of 2. There's your answer for cosine of 75 degrees. Radical 6 minus radical 2 all over 4. Now, since you like high grades on your tests and quizzes, let's check this real fast. Let's go cosine of 75. See that 0.2588 number? Now let's check this. I'm going to go square root of 6 minus the square root of 2. Notice I close that off or hit equal first. And then now let's divide that by 4. Make sure your decimals match up. 0.2588, they match up. I know that this is the correct answer. Okay. So guys, here goes sine of 105. You need to think of this as sine of, I don't care if you use addition, subtraction, but all you can use is the multiples of 30 and the multiples of 45. There's a lot of different ways to do this. The one that came to my mind real fast is sine of 60 plus 45. If you saw something different, then roll with that. Now, I just decided to use the sine of alpha plus beta formula. So you'll look on your note card and see that the sine formula looks like this. I'm going to have the sine of 60 times the cosine of 45 plus the cosine of 60 times the sine of 45. Now guys, some things that don't matter. It does not matter if you went 45 plus 60. All that's going to do is flip-flop these numbers around. So that's not going to really matter. And then guys, I'll launch my calculator on this one real fast, but after that I probably won't, just because we can talk through them. So guys, here goes. I'm going to clear that out. I'm going to have sine of 60 and cosine of 45. So sine of 60, I'm going to put radical 3 over 2. Cosine of 45 is radical 2 over 2. So here's what I've got so far. I've got radical 3 over 2 times radical 2 over 2. There's a plus sign from our note card. Now let me get the next two. Let's go ahead and go cosine of 60 and sine of 45. Okay, cosine of 60 looks like 1/2, which we're going to call 1/2. 45 is 0.707, which you're going to call radical 2 over 2. So I'm going to have 1/2 times radical 2 over 2. Now to bring this home, my common denominator is 4. 2 times 2 is 4 on this one. 2 times 2 is 4 on that one. Now just go get your numerator. Radical 3 times radical 2 is radical 6 plus 1 times radical 2 is radical 2. Stop. That's your answer for the sine of 105. And guys, get in the habit of checking it. I won't check anymore after this one. But sine of 105, I should see 0.9659. Let's go radical 6 plus radical 2. I'm going to go ahead and hit enter, divide that by 4, and make sure your decimals match up. If they don't, then you messed up somewhere. Okay? So guys, after that, I'm just going to list what I would do on that front side. That is really the lesson. That is really the lesson. I am going to come back and do number 15 and 16 with you here in a second. But other than that, let me move on. Here's number 3 and number 4. Like I said, the hardest part is you deciding what to use. Remember, you can use multiples of 30 and multiples of 45. Those are your only choices. Toy around and see if you can get negative 75 degrees out of something. If you toy around just a little bit, the one that came to me was 45 minus 120. So 45 degrees minus 120 degrees look like negative 75. Here's what I really did, guys. I got positive 75. That was my thinking. I got positive 75, and then I just flipped them around. So I just volunteered to use cosine of alpha minus beta. So you're going to go grab that formula off your note card. It's the second one down. So when I start writing this out, I'm going to have cosine of 45, cosine of 120, plus sine of 45, sine of 120. I'm not even going to launch my calculator, because if you go cosine of 45, you're going to see 0.707. So radical 2 over 2. If you hit cosine of 120, you're going to see negative 0.5. If you hit sine of 45, you're going to see 0.707. And if you hit sine of 120, you're going to see 0.866. Every time, guys, when we're doing this, there's a 4. Looks like I'm going to get negative radical 2 plus radical 6, or radical 6 minus radical 2, however you want to write it, over 4. Okay? And then we'll just check it. Here comes my number 4. I'll probably do 4 and then just a couple others with you, because guys, as long as you can go find a formula, that's the easy part. The hard part is right here. I need to go find two numbers that add up to be 195 or subtract to be 195. A lot of different solutions. The one that I saw right off, 150 plus 45. If you use different numbers than I did, no big deal. Go ahead and run yours through as I run mine through. We're going to get the same answer. So I just volunteered to use the sine of alpha plus beta formula. Looks like the third one down on your note card. So I'm going to go sine of 150, cosine of 45, plus cosine of 150, sine of 45. Now you'll grab your calculator and go to work on it. When you hit sine of 150, you're going to see 0.5. Have you got cosine of 45 memorized yet? Radical 2 over 2. Then there's a plus sign. Cosine of 150 is going to show you negative 0.866. So negative radical 3 over 2 times sine of 45, radical 2 over 2. Ending answer, there's a 4. Looks like I'm going to have square root of 2 minus square root of 6. Guys, also notice on these, a square root of 2 shows up over and over, a square root of 6 shows up over and over, a square root of 4 shows up over and over. So we got it. I'll peek at number 5, guys, just to kind of mention the angles, and then I'll turn you loose on that. And then I'm going to jump over to number 15 and 16. Same thing, but they confuse students. So number 5, the hardest part, once again, and like I said, there's so many different ways to do this. I need to come up with a way to get 165. There are so many different ways to do this. The one I used on my answer key is I saw 45 minus 210. Okay. You could also see, if you wanted, you could say, well, wait a minute, 30 and 135 works. Could I go negative 30 plus negative 135? You sure could. So a lot of different ways, okay? Just kind of decide which formula that you use, though. This one you volunteered to use the alpha plus beta. This one you volunteered to use the subtraction one. And guys, if I roll with the ones that I had on my answer key, that means I just volunteered to use sine of alpha minus beta. So I decided to go sine of 45 times cosine of 210, not negative 210, but times cosine of 210, minus cosine of 45 times the sine of 210. As soon as I hit sine 45, you're going to see 0.707. As soon as you hit 210 cosine, you're going to see negative 0.866. There's a minus sign. As soon as you hit cosine of 45, radical 2 over 2. As soon as you hit sine of 110, negative 1/2. Ending answer, look at that 4 in the denominator again. Square root of 2 times negative square root of 3. I've got negative square root of 6. Negative times a negative is a positive radical 2. Or radical 2 minus radical 6 all over 4. Okay? And then guys, we can check it again. I'm not going to do number 6, number 7, and number 8 with you because they're the same thing. I really feel that you should have a pretty good grasp on the lesson right now. If you would, follow me with 2 more. What we're going to do in class is I'm going to have them work on 9, 10, 11, and 12. If you want to pause the video and make sure that if you're doing them right, I will write down the answers real fast if you want to hit pause before I do this. And then you can always come back and see if you know what you're doing. And if you hit pause and you're back, these should be the answers that you're seeing. If you're not, of course you did something wrong. We'll have to get that straightened out. But that's what you should have so far. Okay. And then guys, if you would, drop over to number 15 with me real fast. It says cosine of 270 minus theta. These really confuse people, and I don't know if it's because usually they say prove cosine of 270 minus theta equal the opposite of sine theta, and the word prove throws them off. This is the exact same thing that we've been doing, but here's your alpha, here's your beta. There's your alpha, there's your beta. Now look at your formula sheet for cosine of alpha minus beta and write it out just like we've been doing. I'm going to have this. I'm going to have cosine of 270. I plugged in that number because it's there, times cosine of theta. I don't know what theta is, no big deal. Plus sine of 270 times sine of theta. Now either use your brain in the unit circle to go get cosine of 270 and the sine of 270. If you don't want to use your calculator, here's what I'm going to do. On the unit circle, right there, cosine is the x value. The x value there is 0. So cosine of 270 is 0. You could also go cosine 270 in your calculator. So I got 0 times cosine of theta plus sine of 2 theta. Sine of 270 is negative 1 times sine of theta. Ending answer, the opposite of sine theta. which is what I wanted to prove. So guys, that's all we're doing on those. Here's your number 16, my last one. Here's your alpha. Here's your beta. Ignore that guy for just a little bit. Use your sine of alpha plus beta formula and write it out. So I'm going to have sine of beta times cosine of pi halves plus cosine of theta times sine of pi halves. Either use the unit circle or your calculator. I got a feeling you guys will use your calculator. I know pi halves is right there at the ordered pair 0, 1. So I'm going to have sine of theta times the x value at 90, which is 0, plus cosine of theta times the y value at 90, 1. This simplified to be cosine of theta, which is what I wanted. Okay? So guys, there on your worksheet, on your worksheet, you're going to like this. There looks like there's about 35 problems on your worksheet. If you would, do numbers 1 through 20 for us. Numbers 1 through 20. That's what we covered today. We'll come back and pick the rest of it up next time. Now this will also be on your day 3 assignment. Day 3 assignment. Good luck. If you have any questions, come in and see myself or Miss Dina Han, and we'll get you straightened out. Good luck.